All right, everybody, let's run through 4 problems off of the 8.2 worksheet. Instead of just going in the order that I normally do, I thought I'd pick some of the harder problems to work through with you because there's some odd stuff going on. So let's take a look at number 3. Directions here are to find the missing side lengths, leave our answers in simple radical form. So the first thing we want to do is recognize what kind of triangle it is that we're dealing with. Well, here I see a right angle in the corner there and a 45. As soon as you match up 2 of the 3 angles, 45 and 90, you know you got what you're looking for. This one has to be 45 as well, so this is a 45, 45, 90 right triangle. And in this right triangle, the side we were given right over here, 4 root 6, is across from the right angle, so that's the hypotenuse. So this is the harder of the 2 cases with a 45, 45, 90 right triangle. We were given the hypotenuse. The U and the V that we've got to find are the 2 legs here. So let's get working on this one. We'll go alphabetical order and we'll find U first. So the big important idea in a 45, 45, 90 is that to go from leg to hypotenuse, we multiply by the square root of 2. To go backwards, therefore, from hypotenuse to leg, we're going to divide by the square root of 2. So to find U, we take our hypotenuse, which is 4 times the square root of 6, and we divide that by the square root of 2. Now, in the only example like this that I showed you in our notes, this wasn't a root 6, this was a root 2. And if that happened, the root 2 and the root 2 just cancel each other out completely, and we're pretty much good to go. That didn't happen here because it's a root 6, so let me show you how to handle that. The important thing to understand here is that the 4 is kind of the odd man out in this expression. It's a regular number, a coefficient in front of a radical. There's nothing else here that it can be combined with. But you've got a square root of 6 and a square root of 2 on both the top and the bottom, and those 2 numbers, because they're both underneath a square root, can be combined. All we're going to do, guys, is take the 6 divided by the 2 to get a 3, and our answer then becomes 4 times the square root of 3. There's nothing else we can do to simplify that, so that's our value for U, 4 times the square root of 3. To come up with V, we know that V is the other leg in this 45, 45, 90 triangle, and we know that because this triangle is isosceles, the legs have to be congruent. So if U is 4 root 3, V has to be the exact same thing as U, which is going to be 4 root 3 as well. So that's how you handle number 3. Let's move on to number 8. Again, what kind of triangle are we dealing with? We've got a 90-degree angle here and a 60 right here. So now that tells us that we're dealing with a 30, 60, 90 right triangle. And if you've memorized those side lengths, here's what we know. The side opposite from the 30-degree angle we just call x. The long leg is x multiplied by the square root of 3. And the hypotenuse across from the right angle is going to be 2x. So that's the list that we should have memorized. Now in this problem, we were given 3 root 3 over here on the right, which is your short leg. And from there, this is actually the best of the 3 cases here, we can go in either direction now to find the next 2 pieces. So I guess we'll go alphabetical order. Let's find A. A, right over here, is the hypotenuse of that triangle. And to go from short leg, x, to hypotenuse, 2x, we multiply by 2. So we're going to start with the length of our short leg, which is, sorry about that, short leg is 3 times the square root of 3. That was the short leg, and we simply multiply that by 2. Simplifying this expression, the 3 and the 2 can be multiplied together to make a 6, and the root 3 just tags along for the ride. So the measure of A, the hypotenuse, the longest side, is 6 root 3. B is the long leg. And to go from short leg to long leg right here, we simply multiply by the square root of 3. So our short leg here is 3 root 3, and we're going to multiply that by the square root of 3. Okay, what's that going to do for us? Now in this case, it's the root 3 and the root 3 that are alike that can be put together. So this gets interesting. That 3 right there can't get multiplied by anything else right now, so it just goes along for the ride. Then we now take the square root of 3 times the square root of 3, which is just 3. And now the 3 times the 3 can be multiplied together, and b ends up having a measurement of 9. Now the one thing to be careful of here, guys, remember that the hypotenuse always has to be the longest side in your right triangle. And as you look at these two answers, it might not be clear, but if you type 6 root 3 into your calculator, I'm going to do that for you just to make sure we understand what's going on here. If I type in 6 root 3 and get that as a decimal, that's about 10.39, which is definitely longer than the 9 right here. So yeah, our hypotenuse is our longest side. So I feel pretty good about that answer. Okay, third problem I want to do with you guys, again, one of the tough ones here, is number 9. So what are we dealing with? I see a 90-degree angle and a 30-degree angle. So this is a 30, 60, 90. Let's write all that out again. So a 30, 60, 90 triangle. And again, your side lengths here are x times the square root of 3, and 2x. Guys, the more you make yourselves write this out, the better it is that you're going to be able to memorize it. Now in this problem, they gave us 5 root 6, which was the length of the hypotenuse. The key then is to come up with the length of the short leg next, and our short leg here is b. So to go from short leg to hypotenuse, we would multiply by 2. To go backwards then from the hypotenuse to the short leg, we're going to divide by 2. So b is the length of your hypotenuse, which is 5 root 6, and that all gets divided by 2. Now, what we would normally do in a case like this is take a look at the 5 right here and the 2 right here and say, okay, those numbers are alike, and we can go ahead and divide them. But because that number on top is odd, 5 doesn't divide evenly by 2, there is nothing to be gained by trying to divide that out. And even though this is pretty ugly, guys, that's as pretty as b is going to get. It's not very pretty at all, but that's what b is. Now, we need to figure out the length of a, which means we're now going from our short leg over here to our long leg. And the way we go from short leg to long leg is to multiply by the square root of 3. So a is going to be your short leg, which we just found to be 5 root 6 over 2, and we're going to multiply that now by the square root of 3. Ooh, and this one gets interesting. Okay, what can we do to simplify? We've got a root 6 multiplied by a root 3. We put those together and we get a square root of 18. Everything else just tags along. So this is going to be 5 times the square root of 18 all over 2. But before we put a box around any radical problem to think that we're done, we want to ask ourselves, is it possible to simplify that radical? Does 18 contain a perfect square factor other than 1? And if we're getting familiar with our perfect squares, I think we're going to see this one pretty quickly. The 18 has a factor of 9, which is a perfect square. So this now becomes 5 times the square root of 9 times 2, and a 2 down here on the bottom. Now, I'm going to skip the step here where we normally split these up, but the square root of 9 can be evaluated. So let me come down a level here. The 5 tags along. The square root of 9 becomes a 3. You can't do anything with the square root of 2, so that still keeps the square root sign over the top. And then we have a 2 still down here on the bottom. And the only thing I believe we can do now is multiply the 5 and the 3 together to get 15 times the square root of 2 all over 2. Now, 2 reasons why we're done here. First of all, 15 does not divide evenly by 2, so there's no point in trying to do that. And second of all, the radical that we have, the square root of 2, 2 doesn't contain any perfect square factors other than 1, so that can't be simplified any further. So the value of a, your long leg now, is 15 root 2 over 2. And let's do one more together here, although honestly, this might be one of the easier ones, maybe the easiest one out of the 4 that we've done here. All right, so in 15, what are we dealing with? We've got a 90-degree angle here and a 45, so this has to be a 45-degree angle as well. So this is a 45, 45, 90 right triangle, and your side lengths in every 45, 45, 90 are x, and then the hypotenuse is x times the square root of 2. All right, so again, this is something we want to have memorized sooner rather than later, everybody. And what do we know? We were given 2 root 3, which is the length of one of our legs. Okay, so I'm actually going to go out of order right here and do the easier part first. I want to find y first. Y is the length of the other leg. Well, every 45, 45, 90 triangle, because it has two congruent angles, also has two congruent sides. It's isosceles. So y, this leg up here, has to be the same as this leg here. So you don't have to do any work here at all. Y is going to be 2 root 3, just like the length of the other leg. But to find x, which is your hypotenuse, to go from leg to hypotenuse right here, we are going to multiply that leg by the square root of 2. So the length of the leg was 2 root 3. We multiply that by the square root of 2. Now, we have two numbers that are alike here, root 3 times root 2, so we can put those together and make root 6. The 2 out in front just goes along. Now, the only thing that could potentially happen now is that that radical could be simplified. So ask yourself, are there any perfect square factors that go evenly into 6? 4 doesn't work, and anything beyond 4 is too big. 9, 16, 25, 36, and so on and so forth. None of that works. So that means, everybody, that 2 root 6 is the simplest answer that you could possibly come up with for x. Okay, so those are 4 of the tougher problems on the 8.2 worksheet. I'm hoping the rest of that you guys are going to be able to do pretty well on your own. But if you come across any problems, post those questions in comments, please.